Welcome to Session 3, the distance formula. When both coordinates change, the segment is diagonal. The direct distance is not the sum of the horizontal and vertical changes. Instead, those changes form the perpendicular legs of a right triangle, and the segment we want is its hypotenuse. Today we will build the formula, apply it with positive and negative coordinates, and check whether each result is reasonable. Plot 2 points and draw a horizontal move followed by a vertical move. The horizontal leg has length absolute value of x2 minus x1. The vertical leg has length absolute value of y2 minus y1. Together they meet at a right angle. The straight segment between the original points is the hypotenuse. This picture is the Pythagorean theorem hidden inside every coordinate distance problem. Apply a squared plus b squared equals c squared to those coordinate changes. The result is the distance formula. D equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Use matching point order in both differences. Squaring makes each contribution non-negative, and the final square root returns the measurement to ordinary distance units. Find the distance between 1, 2 and 4, 6. The horizontal change is 4 minus 1, which is 3. The vertical change is 6 minus 2, which is 4. Substitute. D equals the square root of 3 squared plus 4 squared. That is the square root of 9 plus 16, or the square root of 25. The direct distance is 5 units, the familiar 3, 4, 5 right triangle. Now use negative coordinates, -1, 3, and 2, -1. The horizontal change is 2 minus -1, or 3. The vertical change is -1 minus 3, or -4. Squaring gives 9 and 16, so the distance is again 5. The negative vertical change describes direction. Its magnitude contributes 4 units to the right triangle. Check before accepting an answer. A hypotenuse must be longer than either leg, but shorter than the sum of the legs. With legs 6 and 8, a distance of 10 is reasonable because it lies between 8 and 14. Avoid 2 common errors. Adding the legs gives a city block route, not direct distance. Stopping at 100 forgets the square root. The distance is square root 100, or 10. Your repeatable method is sketch the right triangle, find delta x and delta y, square each change, add, take the square root, then check the size and units. Final check. From the origin to 3, 4, the legs are 3 and 4, so the distance is 5. In Session 4, we keep the same coordinate changes, but divide rise by run to measure a line's steepness. www.bridgetoexam.com